isolate equations, right? But most of the equations that we've worked with are, how do you say that? Like they're just polynomials, all right? Or they're like quadratic, cubic, right? Things like this, where things are multiplied or added together. But we haven't dealt with exponential functions yet. We haven't learned how can I isolate an exponential function. Okay? What's the definition of an exponential function? The variable is the exponent, right? So that means if I have, for example, y equals 2 to the power of x, right? That is an exponential function, right? Because your exponent is a variable. Do you guys remember that? Yeah? So what we've done so far, we've done this. If we have, let's say, y equals 2x squared plus 3, I was able to isolate for x, right? By moving the 3 over, by dividing it by 2, and then square root, right? We're all good with that, correct? But we haven't learned how can I isolate something like this. How can I isolate for x when I have x as my exponent? Because I cannot take the x root, right? There is no such thing as the x root. So this is what we're going to look at in the next part of this unit. Okay? We're going to look at some exponential functions. First of all, we're going to look at the laws of exponent. Okay? How can I simplify the laws of exponent? We're going to look at more detailed harder exponent, right? We're going to look at rational exponent. We're going to look at radicals. So we're going to look at all these different things. And then we're going to move to how can I solve an exponential function? How can I isolate an exponential function? Okay? But today we're going to start with the simple laws of exponent, which we've learned that in grade 11. Then we're going to explore the exponent when your exponent is a fraction, right? So what happened if your exponent, if you had y equals x to the power of 2 over 3? What does that mean? We're going to look at that as well. Okay? So there's a few things that we're going to get to before we get to solving exponential or isolating exponential. All right? So this is just where we're heading. So the first thing we're going to do is we're going to look at exponential functions, and sorry, not exponential. We're going to look at the exponent law, and then we're going to see how can we simplify exponent. So first, a power is an expression made up of two parts, right? You have, do you know what the names of these two parts are? The base and the exponent. Okay. So what's your base for 5 to the power of 4? The base is 5. What's your exponent? How about the next one? What's your base? Negative 5, right? And what's your exponent? X to the power of 3? Base is x, exponent. 7 to the power of negative 3. Your base is 7. Your exponent is negative 3. Negative 5 to the power of 3. What's your base? Why is it 5? There is no brackets, thank you. There is a difference when I have a negative 5 and when I have a negative 5, right? When I'm talking about this, negative 5 to the power of 4, or I'm talking about negative 5 to the power of 4, right? There is a difference because in this case, the whole negative 5 is to the power of 4. That's why I have the bracket, so my base is negative 5. But with the second one, only the 5 is to the power of 4. That negative is not to the power of 4, right? So this is kind of like having negative 1 multiplied by 5 to the power of 4. That's how this looks like if I want to write it in more like expanded format, right? This means the negative is a negative 1 multiplied by 5 to the power of 4. Okay? So my base, which is the base of the exponent 4, is just the 5. Okay? And the exponent is? The base here? 3x. And you know it's 3x because it's all in a bracket under the exponent. And the exponent is 3. Mathematically, a power is the repeated multiplication of the base an exponent number of times in expanded form. So that means when I write, like when it's 2 to the power of 3, that's 2 times 2 times 2, right? That's what exponents mean. Now, what would be my expanded form for 5 to the power of 4? Oh, 4 times. There we go. And what would that be? 625? All right. How about the second one? So it's negative 5 times negative 5 times negative 5 times negative. Right? How about if I have this? How about if I have negative 5 to the power of 4? What is that equal to?
It's negative. We get out.
Yeah? Good. So I only write the negative once, and I have 5 times 5 times 5 times 5. Yes? Because the base is just 5. So it's just the 5 that's multiplied by itself 4 times. That negative is only once. It's written once because it's outside. It's not under the bracket. Are we okay with that? So be careful when you're entering in the calculator that negative. Because some calculators, when you put the negative, automatically will put the bracket for you. And you don't want that sometimes. Okay? So I want you to enter this in the calculator, exactly how it looks, and tell me what you're going to get out. What's the answer? That puts the bracket right away for you, right? Right?
Yes, negative 625.
Where's your exponent? It was the bracket. Yeah. So that's, you have to be careful with your calculator. Okay? What did we get? You should get negative, right? Sure. Okay? Next 625, right? So it should be negative. If you don't get the negative, that means your calculator is automatically putting a bracket around your negative 5. So your calculator is assuming, right, that this is negative 5 to the power of 4, which is not the same thing. So what you need to remember is that you're doing 5 to the power of 4, and then you're multiplying it by a negative 1. Okay? So be careful. All right. If the exponent is not shown, its value is 1. Right? So x to the power of 1, right? That's the same thing. 2 to the power of 1 is equal to 2, right? It's the same, it's exponent. All right. So let's see what you remember. Multiplication law. So when I multiply powers with the same base, there's an E there. With the same base, I add the exponent. Remember, you must have the same base, right? So in this case, I have 5 to the power of 5 times 5 to the power of 4. Do I have the same base in this case? Yes. So all what you have to do, you keep the base as is, and then you add your exponent. So that's going to be 5 to the power of 9. How about the next one? Same base? Or do you see the same base?
No, it's 2 and 4. Exponent for x.
Okay.
So time numbers, time 4.
Okay.
Put x and it's an exponent.
Okay. So what would be, not you two, what would be the answer to this? If you're going to do this, what would be your answer? 8x cubed?
6x cubed,
Why 6? You don't, no, you multiply because you're multiplying here, right? It's in the bracket, so there's multiplication. You're only adding your exponent. Okay? You're only adding your exponent. All right? So you multiply the 2 by the 4, right? So that's 2 times 4, which is 8. And then you have your x as your base, same base. Your exponent here is 1. 1 plus 2 is 3, so that's going to be 8x3. Is there any other way that I can solve this?
Can I say or not?
Sure.
Can I make, make the 4 to be the same like the base, the first base? So make it 2 square and x square and then multiplication. Multiply.
What do you mean by multiply? What do you do then?
The numbers with the exponent with the variable. So the number with the number.
And the variable with the variable. All right. So what Sharon's saying is that I can make this as a base 2, right? So that's going to be 2 squared. Now I'm going to even make it a little bit different, and I'm going to actually do this. Look, so I have the 2x, right? And then instead of writing this as 4x squared, I'm going to write it as 2 squared x squared, right? So that's what Sharon was saying. And now what she's saying is I have the same base here, so I can keep the 2 and then make it to the power of 3, and then x to the power of 3. I can even make it a little bit different, because look at this. Both of these have an exponent 2, so I can pull the exponent 2 outside. Now I'm making it a little bit harder. You guys don't need to do that. But you see, look at this. Sorry. Right? Now you see that both my bases are 2x. Now why can I pull that 2 out? Because they're multiplied, and then both of them are to the power of 2, right? If we're going to learn about one of these laws, it's called the distribution law, right? Where I distribute this back in, right? And then you're multiplying your exponent. We're going to learn about that later, okay? But you should know that as well. So you see right now my bases are the same. I have multiplication. I can simply add my exponent. So it's going to be 2x to the power of 3. And then later I can actually bring it back in. But this is making it harder than what needs to be done. Okay? We're going to deal with questions where you have to change the base, as I did right now, where you have to change the base to make it the same base, because that's the only way you can solve. But for this specific case, you don't need to. Okay? You can just do it the simple, old-fashioned way, multiply your coefficients, right? 2 times 4, add your exponent for the x. Okay? This is a little bit like the more advanced, like later on we're going to use. Are we okay with that? Is that yes? All right. If I have the same base, when I divide the powers, I subtract the exponent. So remember, I must have same base. right? So if I have negative 6 to the power of 10 divided by negative 6 to the power of negative 2. Remember that your base here is what? What's your base? Negative 6, right? Because it's in the bracket. So you're going to keep your base. So my base is negative 6. I'm going to keep my base. And what do I do with the exponent? Subtract them. So I have 10 minus negative 2. This negative, I'm subtracting negative 2. So be careful. A lot of people mess this up, right? I remember if you guys had a mistake in my grade 11 was when you had a negative exponent and then you're subtracting. That was the main mistake. So that's going to be negative 6 to the power of 10 plus 2, which is going to be negative 6 to the power of 12. All right. How about the next one? What do you want to do? Okay, so x squared and y squared, but y? Yeah, what's 3 divided by 3 divided by 6? Yep, it's a half, right? So you got the letters, just the coefficient. Okay, good, excellent. So you have, first of all, you're going to have to deal with each letter by itself, right? Because remember, I have to have the same base. If I don't have the same base, I can't deal with it. So I have 3 over 6. That gives me 1 over 2. I can simplify both of this, right? Divide both of this by 3. That would give me a half. Are we okay with that? All right. x4 divided by x squared. If I subtract my exponent, that's going to give me x to the power of 2. What's the exponent on the y? 1. So y to the power of 5 divided by y, that's going to be y to the power of 4.
It's not the same when you write it x squared and y to the power of 4 over 2.
Yes. So you can write it as, also you can write it as just x squared y4 over 2. That's the same. Okay? Any questions about this? What's the power of a power law?
Multiply. Yeah, inside the bracket and put the power outside.
No, I can't read that in here.
Two powers.
You multiply your exponent. All right, so you're going to multiply your exponent. So you keep the base doesn't change, it stays as 3, and then you multiply the 4 times the 5. I want to show you something. Why is that? Okay, so this is the same thing as if I have 3 to the power of 4 times 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 another 3 to the power of 4. Right? Yeah. Right? Now, what I have here is I have multiplication, same base, so I add the exponent. So I have 4 plus 4 plus 4 plus 4 plus 4. So you're 45 times. 45 times. I don't know how that works. You're adding 4 or 5 times. So that's going to be 4 times 5, right? Which is 20. So it's the same thing as instead of doing all of this and then adding 4 plus 4 plus 4 plus 4 plus 4, right? It's as simple as 4 times 5, right? Which is keep my base, write the exponent. Okay. I think I forgot to write. I multiply. How about the next one? What do you get? Negative x to the power of 2. Brackets here. Because your base is already in the front. Okay. Are we okay with this? All right. So this is what I was talking about, which is the power of a product or quotient law. So to simplify a power of two or more items multiplied and or divided, I distribute the exponent to each item being multiplied or divided. So the word distribute means you're going to have to bring it into every single term, every single letter, every single number inside the bracket. How many items do you see multiplied together inside the bracket? The first bracket.
2,
Which are?
3, and x.
What are they? You have to tell me what are they.
Negative.
So I can do -3 as one thing, right? Okay. So you see two items. You see the -3 and the x. Do you see that? Okay. So what's going to happen is that this exponent is going to be multiplied by the exponent of each item that we have there. Okay? So that's going to be -3 to the power of 3, and then x 4 to the power of 3. Right? Now, what happens when I have power to the power? What do? We just did that. You multiply. Right? So what's -3 to the power of 3? Can you tell me? -27. Right? What's x to the power of 4 to the power of 3? X to the power of 12, because you're multiplying your exponent. You're going to have to remember to bring the exponents to the numbers. Okay? That's the one that a lot of people miss. They miss that number. So, in this case, we see multiplication, we see division, right? So that means I can distribute my exponent. So if you're going to distribute your exponent, what do you have? 4 to the power of 2, right? Because you have to bring the 2 in. How about y?
To the power of 10.
Y to the power of
10.
10, because you're multiplying, right? How about to the 6? 6 to the power of 2, because the power on the 6 is 1. Okay, guys, look here. This is probably one of the, if you haven't seen this for a long time, you need to look at this, please. I know people who did that with me last semester, they know what I'm saying. Okay, so we have this, and then we have to the power of 2, right? On the numbers, what's your exponent? What's your exponent on the 4? 1, right? So the exponent here is 1, and this is 1. Okay? When I'm bringing the power to the power, I'm going to have to multiply my exponent. Okay? So if I'm going to multiply that exponent, so 2 times 1, that gives me 2. So that's going to be 4 to the power of 2. Okay? Y, if I multiply 5 times 2, that gives me to the power of 10. Okay? Do we see that? And then I'm going to have to do the same thing to the denominator. 2 times 1. So that's going to be 6 to the power of 2. And then x to the power of 4. multiplying 2 times 2. Okay? What I always tell them, that whenever you have something like this, on the numbers and on any letter that doesn't have an exponent, put an exponent 1. Because then you see that you have to multiply it in. You see how I put the exponent 1 on the 4 and on the 6? Then that's going to remind you that, well, I have an exponent 1 here, so when I'm bringing my exponent in, when I'm distributing my exponent, I have to multiply that by the 1. Are we okay with that? Now, if I want to simplify this, what's 4 to the power of 2? 16. Y to the power of 10 over.
Excuse me, I did simplify first.
That's
Four and six.
Yep.
Make it easier.
What's 6 to the power of 2? 36. X to the power of 4. Do you leave it like this or do you want to simplify? Simplify, right? You always have to look at, can I simplify? All right? So 16 over 36, what can I do? Divide them both by 4. 8. Let's divide them both by 4. If I divide 16 by 4, what do I get? 4y to the power of 10. What's 36 divided by 4? Can I simplify any further? No. Okay, so I'm dividing both the 16 and the 36 by 4 because that's my common factor. What's a 0 exponent law? Anything to the power of 0 is 1. Anyone can explain to us why?
Because it's the rule.
But why? Where did they came? Where did this come? Like why? Why did they decide that anything to the power of 0 is 1? Say it. Yeah.
Something about dividing it by itself.
Yeah. And then, okay, give me an example. Okay, how about x to the power of 2 divided, I'm just gonna, how about x to the power of 2 divided by itself? Right? Anything divided by itself is what? 1, right? When you divide 10 by 10, it's 1. When you divide 7 by 7, it's 1. When you divide 100 by 100, it's 1. X by x, it's 1, right? Anything divided by itself is 1. Good. So, yeah, all right. But then where did they come up with the idea that to the power of 0? Okay. Now,
So not, yeah, 2 minus.
so you're going to have to use the, what do we call it? Yeah, right? The division law. So when I have the same base and I'm dividing, what do I do with the exponent?
Subtract.
Subtract, right? So that's going to be x2 minus 2. What's 2 minus 2? 0. So that's x to the power of 0. But I know that this is equal to 1. Right? So no matter what it is, when it's to the power of 0, it's going to equal to 1. Does that make sense to you guys? Right? No matter, give me any other thing divided by itself. Whatever. Give me something. Huh? 28 divided by 28. All right, that's equal to 1, right? If I have the same base, your exponent is 1 and 1 here, right? So it's going to be 28 1 minus 1, which is 28 to the power of 0. Right? 28 to the power of 0 is equal to what? Right? Anything divided by itself is equal to 1, and when I use the exponent law, that's going to give me an exponent of 0. That's right. So you see this whole expression, 2x squared or 3x squared y to the power of negative 6, all of it is to the power of 0. So that's equal to 1. You don't even have to think about it. All right? Because this whole thing is to the power of 0, that's equal to 1. How about this? Same 1, yeah? Because even if I do the exponent law, right, where I multiply 2 by 4, that's 8. 8 times 0 is 0. So I'm going to end up with 3 to the power of 0, which is 1. How about negative exponent law? Any base raised to a negative exponent is equal to the reciprocal. Yeah. It's I know, reciprocal of the base raised to the same positive exponent. Yeah. Which means, what does that mean? Anyone?
So if we have the exponent negative, so we have to flip the base to the top.
That's right. Flip your base. Whenever you have a negative exponent, you flip the base and make your exponent positive. Okay? So which means if I have x to the power of negative 4, that's the same thing as 1 over x to the power of 4. So I flip my base. Now, why is it 1? Because anything that doesn't have a denominator has a denominator of invisible 1. Right? So what happened here is I flip it, it becomes 1 over x to the power of positive 4. Right? Do we know why? Do we want to know why? I guess not. What? Do you know why?
Because it's a rule. Okay.
Stop telling me it's the rule. Why? They have to have reasoning. They can't just give you rules and say, well, you gotta believe it because I'm telling you so. Why? You should be asking me why, not the other way around. I shouldn't be asking you why. You should be asking me why. Explain to me, why is that?
Because the exponent has to be positive.
But why when I flip it, it becomes positive? Mm-hmm. Keep going. I'm listening. Come. Good. So show me what.
Okay. What's the question was? Sorry, because I
Why x to the power of negative 4 is equal to 1 over x.
X.
Or why when I have a negative exponent I can flip it and make it positive? Show me an example of what. Yeah.
Sorry, not like this.
But why? That's my question. Yes, that's a rule. Why? Okay, give me numbers. Give me numbers. x to the power of 2 over x to the power of 6. Okay, stop. Okay, so you have x to the power of 2 over x to the power of 6. What does that mean? If you're going to do
2 minus 6.
x 2 to the power of x to the power of 2 minus 6, which is what?
Negative 4.
X to the power of negative 4, right? All right, now, how would I do that in any other way if I don't want to use the exponent law? So if you don't want to use the exponent law, you want to use your expanded form. What do you want to do? Do the expanded form for me. So x times x over x times x times x times x times x. All right, that's perfect. Yeah. Now, what happened? What happened here? They cross out each other. So cross out one from the top, yeah? One from the bottom, one from the top, one from the bottom. What do I have left?
The more in the base.
1.
1 over 1,
1,
2,
2, 3,
3, 4. No, x to the power of 4. See how hard it is?
Yeah, I know.
1,
I tried once. X.
no, just write that as x to the
Oh.
power. Okay, now, look here. If I did my exponent law, which is the division law, I got x to the power of negative 4. If I did the expanded format, I got 1 over x to the power of 4. Is one of them wrong, or are they both the same? They're both the same, but they're written in different ways, right? In math, you should not be leaving your answer with a negative exponent. It's one of the rules that you're not allowed to, right? So you always want a positive exponent, all right? But you see here, what is that?
لا بدي احط لهم I will put 1 is over because they wanted to see it.
I just want to leave it as
Okay,
this. Yeah,
okay.
yeah, that's fine. Thank you. Yeah, that's fine. I don't. Yeah, I know what you're doing. 1 to the power of 4 over x to the power of 4. So you see that in this case, right? If I'm looking at this answer and this answer are exactly the same answers, but one is written with a negative exponent, one is written with a positive exponent, because I use 2 different ways, right, to get to the answer. That's why. That's why negative. It's not because it's a rule.
I forgot it actually. We studied last
I
semester.
know.
I forgot.
Does that make
Yeah,
sense
we
to you
had.
now? Yeah? Okay. Now, if I have something like this, some of my exponents are positive. So this is a positive 1, this is a positive 1, and some of them, my exponents are negative. So what happens then? What happens in that case?
So to keep the positive, the exponent that have positive, to keep it as the top, and flip the has negative exponent to the bottom.
To the denominator. Yeah. It's as easy as keeping the positive where they are. Do not change the positive exponent. Just keep them where they are. And then because you're flipping means you're bringing it to the denominator, you're going to bring the ones with the negative exponent to the denominator and make them positive. Okay? You don't change where the positives are. The positive exponent stays in the numerator. Yes? Are we okay with that? How about 1 over 5 to the power of negative 2?
The same flip all
5
5 over.
to the power of 2. Right. So if you look at this, my exponent is negative. So what I have to do is I have to flip my base. In this case, flipping my base gives me a 5, right, to the power of 2. Are we okay with this? Yes? No? Maybe? I don't know.
As you like.
We'll take some time. This needs a lot of practice. All right. base and I'm multiplying, what do I do? So that's am plus n, right? You leave your base, you add your exponent. I have the same base and I'm dividing. You subtract your exponent, so a to the power of m minus n. Power to the power, multiply. A to the power of 0 is? A, b to the power of m. am, a to the power of m, b to the power of m. So you distribute your exponent in. A to the power of negative m. 1 over a to the power of m. How about a over b to the power of m? Over b to the power. How about the last one? B over a to the power of m. All right. Now, what did I want to say? Oh, how about this?
And 2 or 3, we can do it.
Huh?
No. No.
You cannot. You cannot. You cannot. Because it's not multiplied or divided. It's not AB or A over B, right? That's the only time where you can distribute your M in, or your exponent in. If you have addition or subtraction, you cannot. It is not allowed, because then you have to write the A plus B, and then A plus B, and then A plus B, I don't know how many M times, and then you have to FOIL, right? So you cannot. So if I have, for example, if I have x plus 2 to the power of 3, right? In order for me to be able to expand this, I need to write this 3 times, and I need to FOIL too many times, right? So you cannot just bring your exponent in. It's not allowed. It's not acceptable. It's not part of the rule. Okay? Please. All right. Take a break. All right. So if you don't want to go out or take a walk or whatever, you can work on these. I want you to simplify first, then substitute the A, B, and C in. Simplify first, so use your exponent law to simplify, then you can substitute the A in.